Welcome to The Explainer. So today we're looking at something you might actually think is just, a disease of the past. But make no mistake, it is arguably one of history's absolute most successful biological infiltrators. We're talking about tuberculosis. Okay, let's dive right into this. When you hear the word tuberculosis, you probably picture, an ancient relic of the past, right? Like something straight out of a Victorian novel. But the reality? It is staggering. TB still claims well over 1 million lives worldwide every single year. That's a massive number. It is a very present, very dangerous reality for millions of people today.
Here's our briefing outline for today. We are going to track this biological supervillain through 5 phases: the ancient white plague, armor of the infiltrator, the Trojan horse, irrigating the invader, and finally, the cure and the comeback. Let's get to it.
All right, Section 1. The ancient white plague and its industrial explosion.
So back during the Industrial Revolution, you had all this massive overcrowding and poor ventilation, which caused this ancient disease to just absolutely explode in numbers. And humanity's understanding of it actually evolved right alongside its name. The ancient Greeks, they called it phthisis, which literally translates to wasting away. Then, by the 19th century, people called it consumption because, it literally seemed to consume the patient from the inside out. After that, it became known as the White Plague because of the incredibly pale faces of its victims. Finally, in the early 1800s, scientists figured out that it actually forms these fleshy little nodules in the tissues called tubercles, and hence, tuberculosis.
Now, you might be wondering, what's the actual difference between catching TB and catching, say, common respiratory viruses like the flu or coronavirus? Well, notice how viruses are super light. They tend to target your upper airway, like your throat or trachea. But Mycobacterium tuberculosis, that is a very large, heavy bacterium. It completely bypasses the upper airway and goes straight for the deep, deep tissues of your lungs. And because it's so heavy, you typically can't just catch it by briefly passing someone on the street. No, it usually requires prolonged indoor exposure in a really confined space with an infected person who is actively coughing out these aerosolized droplets.
Moving on to Section 2, Armor of the Infiltrator. Let's talk about biological body armor. So how exactly does this heavy, deep-lunged bacterium survive our body's highly efficient natural defenses? Well, its secret weapon is something called mycolic acid. You see, while most regular bacteria have a pretty standard cell wall, mycobacteria are coated in this remarkably thick, wax-like lipid layer. And this waxy armor is just incredibly tough. Not only does it completely block standard antibiotics from getting inside the bacterium, but it actually allows the bug to survive perfectly intact even after it's been swallowed up by our body's own defense cells.
Which brings us to Section 3, the Trojan horse. Welcome to the cellular battleground.
This is where the bug behaves less like a brute force invader and more like a masterful thief pulling off a heist. Step 1. Your lungs are constantly patrolled by these cellular security guards called macrophages, which are literally designed to eat invaders. Now, most bacteria try to run or hide from them, but not TB. It actively seeks them out and just lets itself be engulfed. Step 2. Normally, that macrophage would use a structure called a lysosome to dump toxic acid all over the trapped bug. But here's the crazy part. TB's waxy lipid layer actually blocks that lysosome fusion from happening. Step 3. The internal trap, known as the phagosome, just simply unravels. And finally, Step 4. The macrophage has now been completely hijacked. So instead of being a killing machine, it literally becomes a cozy, protected personal incubator where the TB bacteria can just sit back and multiply unfettered. It is the absolute perfect biological Trojan horse.
So, since our standard weapons completely fail inside the macrophage, the immune system has to call in reinforcements. T cells and even more macrophages close ranks, literally building a walled cellular fortress around the infection to trap it. This fortress is called a granuloma. And what happens inside is intense. The center of this cellular prison often dies off, turning into this dull white, kind of cheese-like substance. I know it sounds gross, but it's a desperate and entirely necessary stalemate.
Now, can you guess how long it takes this bug to divide just one single time? 20 hours. Think about that. Compare it to about 20 minutes for normal bugs. Because it grows so incredibly slowly and it's trapped inside that granuloma without a whole lot of nutrients, it just enters this latent, dormant state. In fact, 90% of infected people keep the bug latent for their entire lives without ever showing a single symptom. But here is the massive danger, and really what you should take away from this. If a person's immune system is ever weakened, say by malnutrition, other diseases, or certain medications, that cellular prison wall can actually break. And when it does, the bacteria leak right out into the oxygen-rich lung tissue. They start multiplying by the tens of millions, creating massive cavities and literally destroying the lungs.
All right, Section 4, Interrogating the Invader. Let's talk about testing our T cells.
Because TB is so good at hiding inside our own cells, our standard antibodies just don't work very well against it. So doctors literally have to interrogate the body's T cells instead. And they do this using two main methods. On the one hand, you've got the Mantoux skin test. This is where they inject purified dead bugs right under the skin. If your T cells remember fighting TB in the past, they'll rush to the site, which causes a hard swelling after about 2 to 3 days. The downside? It requires a return visit to the clinic to check it. On the other hand, we have the interferon gamma blood test. Here, we're basically analyzing the blood chemically to see if T cells release a specific warning signal when they're exposed to TB proteins. The best part? No return visit required. But there is a catch. If you've received the live BCG vaccine, which is actually made from a related cow bacteria, your T cells are going to remember that too, so you might actually show a false positive on both of these tests.
Actually finding this bug in a lab setting, it is incredibly difficult. First off, you need a deep, gunky sputum sample. We're not just talking saliva here, and it's often gathered first thing in the morning. Then, standard lab stains completely fail, all thanks to that waxy armor we talked about. So scientists have to use a specialized Zeal-Nielsen stain, which makes the bacteria light up like little red snappers under the microscope. And to even grow the stuff, labs have to use really harsh chemicals, like sodium hydroxide, just to kill off all the fast-growing normal bacteria from the mouth. TB's waxy armor actually allows it to survive this intense chemical bath. Finally, because it grows at that agonizingly slow 20-hour rate, it takes about 3 long weeks just to see a single colony pop up on a petri dish.
And that leads us to Section 5, the cure and the comeback, fighting the white plague. So here we are at the final act of our explainer, how we fought back before antibiotics even existed. Because, before the 1940s, a TB diagnosis was pretty much a death sentence. But humanity's response was to create sanatoriums, which were essentially these sunlit healing prisons. And amazingly enough, they actually worked. They used constant fresh air to blow away environmental dust, which let the lungs' macrophages focus entirely on fighting the infection instead of clearing out debris. Patients were kept reclining continuously, which reduced oxygen to the upper lungs, where the bacteria loved to thrive. But the most fascinating part? They gave patients cod liver oil, which is packed with vitamin D, and exposed them to lots of UV sunlight. We now know that vitamin D literally activates a specific antimicrobial compound inside our macrophages, drastically boosting their ability to fight off those waxy invaders.
Then finally, in the mid-20th century, antibiotics arrived on the scene. Today, the modern standard of care is defined by what's called the RIPE regimen. That stands for rifampin, isoniazid, pyrazinamide, and ethambutol. Now, why so many? Well, because TB is so incredibly slow-growing and highly adaptable, throwing just one drug at it practically guarantees that it's going to mutate. So hitting it with a 4-drug combination is absolutely critical to defeat this pathogen and stop it from developing resistance.
But, that leaves us with a pretty terrifying question to close on today. What happens when the ultimate infiltrator actually learns to bypass our final line of chemical defenses? Because around the world right now, partial or incomplete antibiotic treatments have given TB the exact time it needs to adapt. And this has resulted in multi-drug resistant and even extremely drug-resistant strains of the bacteria. As these resilient new strains continue to spread, it really forces us to wonder, are we on the verge of returning to the days of the sanatorium, or will our science manage to stay one step ahead of the white plague? Thank you so much for exploring this fascinating topic with me today on The Explainer.